Hi, everyone. It's great to be here. It's so cool to see this event come together, and I'm really grateful to get to participate. It's really fun, and I'm excited particularly to speak about this topic because it's something we've been working a lot on internally on how we really help viewers or help our broadcasters and our customers achieve their monetization goals when audiences are growing, pretty large for some of these digital platforms as viewers transition to live streaming or showing live events on these digital platforms. So we'll talk a little bit about the state of dynamic ad insertion for live streaming, what some of the problems are, and how we can address them today with solutions that exist on the market. And we'll talk about some real-world use cases that we've worked with partners to realize so that they can achieve their goals and support the audience sizes that they have now with targeted ads instead of relying on cached or burnt-in content. So DAI today, there's a super high demand for DAI. Everyone's shifting to digital platforms, as I mentioned. And that is putting a lot of strain on these traditional architectures that are frankly used to video on demand. They're used to really even traffic volumes. Perhaps there's cyclical peaks throughout the day. You can imagine also when there's new content drops, there might be quite a lot of viewership. But I think platforms across the board have gotten very good at supporting on-demand use cases. You just don't see the types of peaks that you see with live sports streaming or live event streaming in general, because everyone sort of has this natural jitter. Like when sessions join, not everyone's going to join at exactly the same time. And so when you interact with the decisioning architectures and decisioning tech stack that actually serves these ads to your viewers, they don't have to deal with these super high spikes, up to tens of millions of viewers. DAI infrastructure is going to struggle with that high concurrency because it just is not built for that. There's a lot of stuff that happens behind the scenes, behind your ad server with DSPs and SSPs. There's real-time bidding for programmatic ad insertion. It's a lot of stuff that goes on, and a lot of these systems are just not built for this super high concurrency where you have a thundering herd of viewers that all arrive at once. And that's going to cause all sorts of bad effects on your system. So if you are, driven by monetization and you would like to be able to insert ads and you'd like to be able to support that, you might actually have some viewer impact as it takes longer to get these decisions. If you're using manifest-based protocols, it might take longer to produce a manifest. And if you're running really close to the live edge, that might result in buffering. Worst case, it might result in a stream failure, depending on how your player is implemented. It's really bad. You can solve this potentially by adding more latency. So if you know that your tech stack is going to take a long time to resolve everything it needs to resolve in order to show the stream that you want to show with the ads you want inserted, you can just add latency. But that gets really bad. I mean, especially with live sports streaming, what if someone's using a different platform and licensing is allowed multiple providers, and all of a sudden someone watching on a different device or a different service gets to see the game before you, and they tweet about it, and then you've ruined whatever event it was. So it's not a great outcome. You don't want to compromise the viewer experience just to deliver more ads or more lucrative ads to your customers. So what do we do? It's going to be hard. I won't lie. These problems are not easy to solve for, and there are real trade-offs that you have to make in order to figure out a solution today. But they do exist, and we're gonna talk through some of the ways that you can manage this complexity for your live event workflows. So why is it hard? We've said it's hard. We've explained a little bit about the back-end ecosystem. Concurrent viewers are going to hit tens of millions of viewers. We just heard about the Super Bowl and Tubi hitting 15, 16 million viewers, and hundreds of millions of viewers in the future. There's other properties like cricket and other types of sporting events that are going to drive just these really, really large audiences. And that is hard. Like that is just dealing with that is hard. As we learned, like you need to implement heavy caching, and it's going to put a lot of stress on all of that backend system. As I mentioned, ad insertion happens in real time. It happens all at once for live sports, and those services are not necessarily going to be, those services involved in supporting those breaks aren't necessarily going to be able to support that scale without advance notice. So this is where forecasting comes in. So you have to tell all of your partners, hey, we're going to have this event and it's going to have 10 million viewers. And as we've learned, those forecasts might be wrong. and you better hope that they scaled up more or they have extra capacity or headroom that they can support your event. And that's just, it doesn't make me sleep well at night. And I know that a lot of operators it's just something we dread because it's really difficult to know with certainty that you've provisioned the capacity that you need. And so there needs to be something else that you can rely on to guarantee a good outcome. And then this is what I mentioned earlier, adding extra latency it's just going to degrade the viewer experience. We want to avoid that. So let's talk about a potential solution. There's this notion of prefetching. So ad prefetching is the idea that I can predict the future. I can look at upcoming ad breaks and say, I'm going to need some ads. I would like to deliver them to these viewers in particular and have them ready ahead of time. This is great in theory. So what exactly are we talking about? We want to allow publishers to retrieve decisions before they're needed. We have to set up the right ad tag, which is basically to say the parameters that you want to send to the ad decisioning tech stack to figure out like what ads should be returned to viewers, and ensure that happens before you need it. We use a protocol called VAST to serve ads, and we store that for later use at some point. So we'll make at some point in the past or ahead of the ad break, we'll make a call to the ad server, we'll get a response, we'll store it, and we'll hold on to it for that viewer until the ad break arrives. In theory, this improves insertion rates because you can also do conditioning on creatives. So if you're doing programmatic ad insertion, you can hopefully, if you need to make adjustments to the encoding or to the packaging of those ads, you can do that ahead of time before they're actually needed. So this sounds great. Take my money. This is a wonderful solution. But in practice, I'm not quite sure if I answered how that solves for scale, because if you just move stuff up, doesn't that mean that all these people are going to need ads all at once anyway, and you're just doing it ahead of time? Doesn't seem like I'm solving any architectural problems here yet. Also, like this predicting the future business is kind of tricky, right? How do I know what parameters I'm supposed to ask for ahead of time? That seems like a hard problem. And then this one's a really interesting one. You might be in an environment where there are regulations about what ads can and can't be shown at what times. And so if you are prefetching or if you are getting ad decisions ahead of time, how do you know that those are the right ads to show later? Or conversely, maybe there are restrictions on the type of ads that can be decided at a certain time, and those restrictions relax later on. So you might be missing out on some revenue for serving higher value ads if you're making a request early and then something about the regulatory environment changes, like the time of day or whatnot, such that you might have been able to serve different ads. So this becomes a pretty big challenge for maximizing your revenue. So let's talk about scale first. Traffic shaping is a really useful mechanism to spread out the number of requests that you have over time. You can instruct your backend server to say, all right, well, let's cohort all of these viewers and we'll put them into groups and we'll make requests for these groups at one at a time or something, or over some bucketized period, right? That'll help solve for this peak. So we can do prefetching, and because we're doing it ahead of time, we have some extra, wiggle room, so to speak, to add jitter and to help reduce the peaks that these decisioning partners have to support. We also want to ensure that as people start streaming, we start prefetching immediately. So there's natural jitter when viewers join the stream, and you're going to get an opportunity when that happens, whether or not there's an ad break coming up to fetch a bunch of content. And again, this depresses the number of viewers that need a decision all at once when that ad break actually arrives. And then we want to also be careful when we're gaining new viewers or when we're doing these prefetching. We want to limit the amount of work we're doing for individuals, because you can imagine going crazy here. Like, let's say I want to get all of the ad content I could possibly serve for any viewer, and you might end up making tons of requests to your ad backend all at once. And now if you have a lot of viewers, you might end up doubling or tripling or quadrupling the amount of work you're doing at any one time, and thus foiling your attempt to lower the load on those backend systems we're trying to protect. So effectively, we just want to turn a graph like this, where you've got millions of requests happening all over really short time, to a graph that looks more like this, where you've reduced it by like an order of magnitude. You have this really steady rate of requests over some minute or 2 minute period that allows you to protect those backends, so they're not doing all this crazy amount of work. It allows them to have better economics and better scale, and it just helps everyone out a bunch. Again, I would be skeptical. This sounds all theoretical and all great. So it's important that we talk about how we do this in the real world, right? We'll talk about a case study now with one partner that we worked with who actually helped us develop this prefetching feature for MediaTailor and for their use case. So I'm going to describe what we did with KO Sports. KO is a streaming platform in Australia. They're the largest sports streaming service in that region. They're part of the Foxtel group, which is now DAZN. They're built on AWS, and they serve up to 400 professional, amateur live events each week. It's really an impressive platform. They do a lot of stuff. That ends up being like 20 to 50 simultaneous event streams. Australian football, rugby, Formula One, supercars, all this stuff. It's really quite a broad array of events that they're supporting, and all of them have different requirements and different ad request patterns and different viewerships. Some of them are high viewership, some of them are low viewership, but it's really quite a mix, and so that makes it challenging to support from a prefetch perspective. So the problem, these ad breaks that KO Sports was supporting for some of the larger scale live events, even below millions of viewers, when you reach millions of viewers, there's certainly going to be problems in ad tech stacks, because a lot of those services can't handle super high TPS in general. But even for smaller live events, KO was finding that they would overwhelm their DSPs and SSPs almost immediately. Every single ad break, they would go down, and you'd see tons of timeouts. And the unfortunate thing about that is that if you take too long to decide these breaks, you're going to do one of a couple things. Depending on how your ad campaigns are organized, you might underfill a certain break, and that results in these really weird situations where you have 3 minutes of time, but you can only fill 1 minute of that time, and then maybe you have 2 minutes of slate content, or maybe there's burnt-in content, and you end up crashing into the burnt-in content. So you have this targeted ads that sit on top of the content, and then you crash into someone else's ad. It's a really bad experience, and we really don't recommend it. And so they implemented a feature actually with us to just drop all of the targeted ads if you ended up with this viewer experience that would be really bad, where you'd end up with a really long slate or really long unfilled time that could potentially impact viewer experience. And now you're leaving money on the table. Now you have this 3 minute ad break that you wanted to fill, and all of a sudden you can't, even though you got some ads back, you can't insert anything. That's just really, really bad. So this is lost revenue opportunities, underfilled due to timeouts, and they wanted to take on a goal of boosting their ad fill rate above 70%. So that's what we want to try to solve for here. One key challenge that they were dealing with is that ad breaks are dynamic, right? Especially in live sports. The duration of an ad break, the position of an ad break might change. There's some rules that govern what content I alluded to this earlier, but what content can be shown at what times. Gambling ads, for example, are not allowed between, I think it's 8:30 in the morning to 5:30 in the evening. I'm not exactly sure of the regulations on that, but it's a certain time of day, and you're not allowed to show those betting ads. they're quite lucrative, but you can get in trouble. It's like a 3 strikes you're out policy on violating that regulation, and we really want to make sure that doesn't happen. If ad breaks shift in time, you might not be allowed to use the prefetched ads, which is really tough, and that changing duration of ad breaks is just really odd, because you have to sort of know in advance like how much content you want, and then make sure you ask for at least that amount of content. And there's some other challenges with that we'll get into a little bit later that we want to sort of talk through. Basically, the way that we solved for this was to allow viewers to describe the breaks that they're prefetching for ahead of time. So when you configure a prefetching opportunity or retrieval, you want to give conditions under which that retrieval can be utilized or consumed by the stream or by the viewer. That involves like defining like the duration or the minimum duration of the content that you want, particular metadata that might describe the break, and we can get into some of that a little bit later. And basically want to give, as best as you can, a description of how these ads ought to be used. And that allows you to do a couple things. You can prefetch multiple types of ads or multiple types of opportunities at a time. That allows you to use those different types of ads under different circumstances. So what happened? We basically worked over a 6-month period or so with the KO team to like prototype and then build this prefetching solution. We wanted to try to identify bottlenecks in the system to understand like what it would actually take in order to properly build the right request cohorting and prefetching strategy. Also to like figure out how to create a useful configuration mechanism with them so that they could express all of the things they needed to express about the business rules that we're solving for. Because remember, it's not just about the scale, but about how these ads are ultimately going to be used and consumed by viewers. A key part of this was actually working across the delivery stack and the ad tech stack to optimize timeout settings. Something that's really tough, you don't ever want to have a situation in which your client and server timeouts are wonky, where one client is waiting on the server and the server ends up timing out before the client actually does anything. It gets to be these really awkward cascading timeout failures where you might end up locking up your system or your client waiting for a response, and you want to be able to ensure that you stack these timeouts so that everything closes. You don't want to end up with like loose connections that are not they're not being utilized and taking up resources on your back end or on your client. So it's very important to get that right. The KO team and we spent a lot of time trying to figure out how to balance how to maximize the probability that you could get an ad response with the latency requirements of the viewership or the viewing devices that we were working with. And that required some just careful coordination across these partner services. They also did some things on their back end in the ad tech stack that is really interesting. They increased the number of ad server line items, and they introduced a couple of house creatives at varying durations, like 6 seconds or something. One of the quirks about targeted ads or personalized ads is that although they're often advertised to us in like nice round number durations, like 15 seconds or 30 seconds or something like that, it's often not the case. These creatives are like maybe 31 seconds or 29 seconds or 14 seconds or 16 seconds. And when you're trying to like fill a break, and have a good experience where viewers, they leave the stream, they enter the ad break, and then they come back at the ad break. They want that to happen seamlessly. And if we're stitching together a bunch of ads that are all of different durations, you might end up with this like awkward amount of dead time at the end. And you want to fill that with something useful that the viewer can actually enjoy, and that doesn't result in either slate or you crashing into other content underneath. And that helped fill out like empty space, especially if some of those back-end timeouts were hit. and we didn't actually get decisions for all of the targeted ads that we wanted to insert. And so this is also a way that you can ensure that your timeouts are kept if you have house ads or if you have something you can serve in lieu of a targeted or paid ad opportunity. And as a result, they blew through their goal of hitting 70%. They're about at 90% fill rate, or 95% fill rate, I'm sorry, for their ad revenue or for their ad outcomes for each of these breaks since implementing this solution. It's super effective. If you understand the targeting requirements, if you understand the conditioning requirements of the stream, then you can really achieve some good outcomes with this. But you have to be very careful about the business rules to make sure that they're consumed and used appropriately. So let's talk about what we've actually done. So recently, we've launched some simplifications to how these schedules or how these prefetching mechanisms are orchestrated. One of the things we discovered with KO is that it can be kind of cumbersome, and especially when you have lots and lots of live events going on, it's cumbersome to schedule these things. We work off of, because of the business requirements around gambling ads and whatnot, we work off of fixed time schedules, and so you pick a point in time of day that you want this retrieval to occur, and then as sessions join within that retrieval window, they might get ads. But that all presupposes that you kind of know when the ad break is happening. As we learned, ad breaks can shift, or new ad breaks can be introduced, and so you have to find some way to recoup or recover when an ad break happens unexpectedly, or when more ad breaks happen than you had planned. And so we recently introduced this idea of a recurring prefetch retrieval that happens after each ad break to simplify the scheduling mechanism. So you can still define start and an end time for when these events or prefetches can be valid, but we want the ability to sort of re-up and fetch more content if needed throughout the life of the stream. The other thing we did was we tweaked our traffic shaping algorithm a little bit to help further reduce peaks to ad servers and other dependencies. We've been working on this continuously through time because Media Tailor is a manifest stitcher. And we do all of our work based on interactions with the clients for manifests. So when a customer or when a viewer asks for a manifest, they'll request to us a playlist. We'll fill that playlist and stitch whatever ads are supposed to be stitched in, and then return it to the client. And the client's basically heartbeat on a segment cadence. We need to be careful and figure out how we can schedule these prefetch requests based on those cadences. And so there's been a lot of work done in the last few months or so, really over the last few years, to ensure that we get really smooth distributions of sessions as they make requests on those segment boundaries. The other thing we're doing is expanding our feature set to allow expiration of ads. So I mentioned the regulatory requirements for specific times of day, but you also may want to support expiration of old decisions. So if you make a request for ads way in the past, 2 hours in the past or something, and this viewer is still watching, but you haven't actually seen an ad break. There's lots of content like this, or maybe not 2 hours, but you can imagine for football, soccer or something, there's usually 2 or 3 ad breaks in the whole broadcast, once at halftime and maybe once after the show, or maybe a pregame show ad. And so you can go long periods of time without there being ads. So you may want to get a fresh ad decision from the ad server with newer metadata that more accurately reflects either the content that you're serving at that time or certain characteristics of the stream or the viewer. So you can expire old decisions, throw those away, and then refetch new content before the break arrives. And then finally, we've done some work to expand the targeting criteria. These are the conditions under which things can be consumed, adding additional support for additional SCUDdy metadata, deciding what break type, segmentation type ID to decide if you're going to do a particular kind of advertisement. So you can orchestrate different types of ad opportunities, and that's you could also use other fields or other properties of SCUDdy 35 to really get quite specific in the type of ads that you're retrieving. I'll just give a brief example of like what this actually looks like. It's fun to talk about it, but it's helpful to see a picture of like what prefetching actually is. So you define sort of this blue window here, which is your start and end time of when you're going to allow for ads to be retrieved. So you start at 7 p.m. and ends at, I guess in this one it's like 8:45 or so, and that's your sort of event window. That's when you expect that ad breaks are going to occur. At the very beginning of that, at some point, the session is going to join and you'll get a bunch of ads. And each of those pink blocks is an ad break. And so after those ad breaks occur, we consume the ads theoretically that we've prefetched, assuming that that ad break is correct. And you can define things like a delay after the avail, or after the ad break, I should say, that then allows you to say, okay, I've consumed this prefetch, I want more ads. That occurs over a traffic-shaped window. So again, we don't like have a huge spike for every viewer right after they consume one ad break. And then define that expiration timeline for those retrieved ads. And then that process repeats. It's a little bit hard to illustrate over many, many ad breaks, but you can imagine the same thing happening after every break. You consume ads, you wait some time, and then you retrieve more ads, and then hopefully the next break occurs within the retrieval window or within the expiration timeline. Oh, all right. So stuff we've learned. We're right on time, good. So dynamic ad insertion for high concurrency live events is super hard to support without prefetch today. There are other potential mechanisms that we can talk about also, but they're still being planned and discussed. It does require careful planning to do prefetch though. It's hard. I'm not gonna lie, it's a difficult process to orchestrate. We work very closely with our partners to try to hopefully build tools to make it easier for folks, but it does require a lot of careful planning. Timeout settings across the delivery stack and across the ad tech stack need to be optimized. That includes your CDNs, SSAI platforms, ads partners, clients. You need to look at that holistically and understand, all right, from, if I had a worst case scenario where everything times out and all of my systems are down, what does that actually do and how does that happen? You want to be able to recover from these kinds of failures. And then finally, I mentioned that ad creatives aren't always, 15 or 30 seconds. Short form ads, house ads of varying durations, those can help fill in gaps when things don't quite work out, when your planning isn't perfect. It helps to have some buffet or fallbacks that you can use to fill in those gaps so that you don't necessarily lose the ad opportunity entirely if the fill isn't quite perfect. And then the last thing, not all breaks can be filled with the same type of ads. You want to use matching criteria and expiration timelines to ensure that delivery is appropriate and allowed. Do not violate any regulations by fetching the wrong ads and then showing them at the wrong time to viewers. That can be super bad. I want to say a particularly heartfelt thank you to the KO Sports team. They're fantastic partners. It's really wonderful to be able to work with them. We wanted to try to get them to come here, but unfortunately the timing didn't work out. But it's been just an absolute pleasure to work with their engineers. They are super great. And it's just really impressive, the solutions that they've been able to build to deliver these very, very high concurrency events to their customers with monetization. And that brings me to the end. We're right on time. Okay. So yeah, if there are any questions, I'd be happy to answer them. Thank you.